Okay guys, welcome back. Let's talk about page 168, where it gives you yet another way to come up with partial quotients. And this way that they are wanting, this strategy that they're wanting to teach you is has to do with partial quotients using rectangular model or area model. And so it's the same word problem that we talked about on page 167. This is just a second strategy for coming up with those partial quotients to figure out the entire quotient. So at camp, there are 5 players on each lacrosse team. If there are 125 people on lacrosse teams, how many teams are there? And of course, we discussed in the last video that our division problem or our equation would look like this. 125 people divided by 5 players in each group would give us our quotient and would give us the answer to the question, which is how many teams are there, okay? So just keep in mind that's the question, and you have that on your book, so I'm just gonna take this down. Okay, so before we go over this other way that they're wanting you to do this with rectangular model, I wanted to remind you about area model, okay? Rectangular model and area model are exactly the same thing. And so in the same way that when we did multiplication and we found partial products using area model, you can also do division using area model. So I wanted to remind you just a minute to quickly cover just 2 examples of partial products using area model, okay? So remember that multiplication is just the opposite of division. So our first problem is 25 times 5 equals what? And we're trying to find the product. So in our area model, we would we would break 25 apart into 20 and 5. And so we would draw our box here. And we would put our 5 over here. We don't need 4 boxes this time. We really only need 2 because we don't have a double digit as our other factor. So we only have 1 here. So we're going to say 20 and 5, okay? So then 20 times 5, I hope that you all know this very quickly, is 100. And 5 times 5 is 25. And so we would add these 2 partial products here together to get 125. And that would be the answer to our question 25 times 5, okay? That would complete that equation. 25 times 5 equals 125. All right, we're gonna do one more, 4 times 32. And in the same way, since we only have 1 digit, we only need 2 boxes instead of 4 because one of our factors in this multiplication problem only has 1 digit. Okay, so we're going to put our 4 over here, and we would break 32 into 30 and 2 because it's always easier to multiply by tens, okay? And since there's a 0 in the tens place here, 4 times 30 should be fairly simple. The first thing that we should notice is that we know that 4 times 3 is 12. And so 4 times 3 is 12, and then we add our other 0 here. So if 4 times 3 is 12, then we know that 4 times 30 is 120. And then we say 2 times 4 is 8. And so we add 120 and 8 together, and we get 128. And so then we know that our product for this question, 4 times 32, is 128. Okay, so there is a brief review of reminding us what we did on area model when we were talking about multiplication. So on the flip side, your book gives you 2 examples of 2 different people, Jared and me, who did the problem in 2 different ways using the same strategy of area model or rectangular model. They just did it a little bit differently, and as you can see, the way it's laid out on your paper is exactly the way that I laid it out on mine here. This is what you should see on page 168. Yes, that's correct. And so what Jared did is he first divided 125 into 50 and 75, okay? And he knows that what would go here, do you see how we're just filling in a different spot? Now we need to fill in what this factor is and not what our product is. We already know the product, so what number times 5 would give me 50? And that number is 10, okay? So this is the first step. He would take, he knows that one of the factors here is 10, so he's going to subtract that. That gives him 50, I'm sorry. And so 125 minus 50 is going to give him 75, okay? And then it's going to show, we already have this part, okay? That's what that's showing. We're not adding all of these together. This is just showing the first step here. What he did then with 75 is that he divided that on out, or broke it apart, I'm sorry, not divided. He broke it apart into 50 and 25, okay? To make it a little bit easier numbers to work with for him. And so Jared said, just like I know that 10 times 5 is 50, I know that again, so this one is also going to be 10. And so I can subtract, 10 times 5 is 50, I can subtract another 50 here and get 25, okay? So if we go ahead and just finish this up, I think this may be already done for you in your textbook. I just wanted to show you that this was step by step and that we don't go back and add up all of these in the different steps, okay? We've got 50 and 50, and then this final 25. We know what the product is here in this area model. So what number times 5 is going to give us 25? And of course that number is 5. So 5 times 5 is 25, and 25 minus 25 is 0. What Jared is then going to do, and what you would do if you use this strategy, is you're going to add up your partial quotients up here. Just like these were our partial products, these are our partial quotients. So 10 plus 10 plus 5 equals 25. So again, the answer to the problem, 125 divided by 5 is 25. That's the quotient. Right there. Okay. So my, or me, however she pronounces her name, she does hers a little bit differently. She only needs to divide this one time because she recognizes something quickly, that 125 can be broken into two numbers that she can work with really easily, and those numbers are 100 and 25. Okay, see how they're the same? And this is going to be important when we start talking about equivalent fractions too as well. So we have our products in here. So what number times 5 would give us 100? And hopefully you know that pretty quickly, and you know that it's 20, plus it's already right there in your book. 20 times 5 is 100. So I'm going to subtract 100 from here. 125 minus 100 is 25. That leaves me with this 25 left over. Go ahead and fill this in for this step here. That's my 25 that's left over. What number times 5 is going to give me 25, and of course the answer is 5. 5 times 5 is 25, and again that's 0. So my, or me's, partial quotients are 20 and 5, which of course equal 25, which is the same thing that Jared got. He just took another step, an extra step than she did. And that's totally fine. So if you discover that this strategy works for you, then that's fine to use that strategy as well. What I would do is encourage you to practice a couple of those on some problems on page 169, even if you want to do some of those today, even though it's technically not your assignment until tomorrow. Go back and just watch these videos if that helps. You figure out the one that works for you, okay? That's what these are strategies. You do not have to do them exactly this way every time. And I'm never going to require you to show me how to do it this way, okay? So figure out the one of those that works best for you.